Background. Hydrogen peroxide is a strong oxidizer and is used as a bleaching agent and disinfectant. Concentrated hydrogen peroxide, or high-test peroxide, is a reactive oxygen species and has been used as a propellant in rocketry. Hydrogen peroxide is also one of the two chief chemicals in the defense system of a bombardier beetle, rejecting the hydrochlorine to discourage predators. Reacting with. The ejected fluid is 100 degrees Celsius and causes burns. The decomposition of hydrogen peroxide in aqueous solution proceeds very slowly. A bottle of 3% hydrogen peroxide sitting on a grocery shelf is stable for a long period of time. Take time to look over the equation that is provided for you in your lab. Objectives. In this experiment, you will conduct the catalyzed decomposition of hydrogen peroxide under various conditions. You will calculate the rate constant for the reaction. You will determine the rate law expression for the reaction. You will calculate the activation energy for the reaction. Determine the rate of decomposition of hydrogen peroxide. DCAP, Alternative Lab. Make sure you do your pre-lab questions because you need those calculations for number 6 for your lab. More background. A number of catalysts can be used to speed up this reaction, including potassium iodide, manganese fluoroxide, and enzyme catalase. If you conduct the catalyzed decomposition of hydrogen peroxide in a closed vessel, you'll be able to determine the reaction rate as a function of the pressure increase in the vessel that's caused by the production of oxygen gas. If you vary the initial molar concentration of H2O2 solution, the rate law for the reaction can also be determined. Finally, by conducting the reaction at different temperatures, the activation energy, EA, can be calculated. Setup. Here are a few things. I'm going to set both my probes up. I have the wireless units here. I've got the gas probe and I've got the temperature probe. Okay, and that's ready to go. This is actually still open right now. That's going to be closed. All right. I'm using 125 milliliter Erlenmeyer flask. I'm going to make sure that this fits good into there. We're going to talk about how you got to take that off and put it in there, and if you do it right, you can actually just shake, and that'll work just fine there. Okay. If you want to get a little fancier, you can get the magnetic stirrers and magnetically stir it. Okay. So we've got it all set up, and now we're going to follow the instructions. Okay, you have 4 runs to do. Make sure you look over the table, and it will tell you how much for each run you're going to have of the hydrogen peroxide, the water, and the Ki. Your 4th run needs to be done with a low temperature, and so you're going to put that on a cold water bath, or you may put it in the refrigerator while you're waiting to do that run. Okay, so that's going to be the 4th run that we're going to lower that temperature. We want that temperature to be at least 10 degrees cooler than the room. All right, so first things up, we're going to add the 45 milliliters of water to our beaker, flask. Okay, and I want to go ahead, it doesn't exactly tell you to, but you want to go ahead and get a starting temperature of that. And you're just going to have to physically record that as our starting temperature is going to be. All right. Okay, I've measured out exactly 10 milliliters of the 3% hydrogen peroxide, and I'm going to place it in the flask as well. Now for me, this might be a little bit colder because I brought it out of the fridge. All right, we're going to shake it just a little bit, make sure it gets all mixed. And then I'm going to put it back in there, get my starting temperature again of what I'm starting with. Okay. All right. So I've got that in there. Now, if we're lucky enough to have syringes, then you'll use a syringe to put in there. Okay. If not, we're simply going to take what we have and we're going to pour it in there. you want to make sure that you're prepared and ready for this, okay? Make sure that your timer is going to go for at least 3 minutes. And so I'm just going to go down here and just check that. 3 times 60 is 180, so I've got in collection after 180, so we're good. Okay? So let's do this, right? So we're going to, this is closed. I'm going to pour it in there. I'm going to seal it. And we're going to let that reaction go and keep mixing it. Okay, so when it is done, you're supposed to go in here and you're supposed to pick out where it is the steepest. Okay, so the steepest part for 20 seconds. And you're going to perform a linear fit on that portion there. So if we're looking at this, we can blow it up. Like I said, it has to be at least 20 seconds. That looks pretty steep there. We'll apply a curve fit, linear, apply. Okay, and I want to go ahead and screenshot that, and I also want to make sure that I save that, right? And you're going to need that for your slope, because remember the slope tells us something about the rate of reaction. So let's go look at the other ones real quick. Okay, so round 2, I'm going to have 50 milliliters of water. Again, I'll get that temperature. I'll record that. And then we have 5 milliliters of hydrogen peroxide being added to that. So we'll get our starting temperature. And then once we have that, gas probe. Everything's working right. And we're going to dump the Ki into it, and we're going to press collect and let it go for 3 minutes. So here we go. Make sure it seals real well. And collect. This will work better when you have your partner. Okay, we're gonna let that one go forward and we'll see what we get for our results. Okay, trial 3, we're gonna have our 45 milliliters of water. Again, we're gonna go to temperature of that before we start. And then we're gonna add 5 milliliters of hydrogen peroxide. And we'll get that starting temperature. And then once again, this time we have 10 milliliters of potassium iodide. Got our starting temperature. We're gonna pour it in there. We're gonna cap it. And we're gonna collect. And again, swirl. All right, the last run is gonna be our 10 degrees at least underneath our starting temperature. So here's my water, and I'll have 45 milliliters of water. We'll get a starting temperature of that, and hopefully we've dropped it. Okay, it'd be preferred if you do an ice bath instead of I just had it in the fridge. All right, but we're gonna at least shoot for at least 10 degrees below. And looks like we're almost there, right? Okay, looking pretty good. so almost 10 degrees below, all right? And here's my hydrogen peroxide that's also been in the fridge, getting nice and cold. All right, so I'm at 9 degrees, so about 10, that's okay. All right, here we go. Last one. I've got my gas probe ready to go. I've got the KI that's also been cooled off. All right, 8.9. Put it in there. And collect. And you can also hold it like this and shake it. And we're gonna let this reaction go, and this is the one that's supposed to determine our EA, right?